The first one will be Todd Carpenter. He's the managing director of NISO, followed by Terry Mitten. She is the data products project manager at OECD. The webinar today will focus on learning about the development of standards to manage data sets and to handle data sets for publications. The questions for the session will be answered at the end of both speakers as time permits. If there is no time to answer the questions, the speakers will answer those questions offline. So without further ado, I'll turn it over to Todd.
Okay. I'm presuming everyone can see the slide, the introduction slide, correct?
Yes.
Great. It's hard to tell what can be seen by other people in my on my screen. Just a little bit about my organization before we get started. NISO, the National Information Standards Organization, is a nonprofit industry trade association accredited by ANSI, the American National Standards Institute, to develop technical standards related to information documentation, discovery, and the distribution of published material and media. We have roughly 110 members, roughly divided in thirds between the publishing community, the library community, and service and support providers and software providers. As publishing first developed, what we hardly think of standards today, but when you pick up a book, when you pick up any printed media, you're really picking up a real package of standards and standardized things. Page numbers, tables of contents, indices, cataloging information, title pages, paper, binding, sizes, ink, all of these things have been standardized over decades and centuries. Although these things don't have official ANSI, NISO designations, they certainly are de facto standards and best practices. So even though a lot of people think of standards as something that's a bit of a black box, they're very familiar things in our landscape. So we're going to talk today about data publishing, and data distribution. There's been a great deal written of late about the growing prevalence of data analysis, and data sharing in science. This is just one of the works that was published recently. If you haven't taken a look at it, I highly recommend it. The Fourth Paradigm, edited by Tony Hay, who's the head of Microsoft Research, and a number of others. It's freely available online and certainly worth your time taking a look at. And it discusses the ways in which advanced science is really being taken on and powered by the advanced computing capabilities to really focus on data-intensive science. So science certainly has changed a lot, and so too have the ways that scholarship and communication is distributed. Increasingly, science is no longer communicated in paper. There are very few scientific journals that are distributed in paper any longer. But increasingly, information is distributed electronically, and this has opened up the door for a variety of approaches to large-scale data analysis and data visualization. And a number of scientists are taking advantage of the opportunities provided by digital distribution. Of course, this presents a variety of challenges when it comes to data publishing and data sharing. Data is unlike traditional publishing in a variety of ways. It's certainly massive, or at least it can be massive in scale. It certainly is often constantly changing. It's difficult to describe and catalog in traditional ways that librarians are used to doing with texts. It's difficult to integrate with other data sources, and certainly complex to analyze. You can't just look at a data set and glean information from it. You often have to use tools or analysis packages, etc. Things like peer review are often very difficult to do on a large-scale data set. It's difficult to curate. It's certainly challenging to preserve. So based on these characteristics, there are several complexities related to managing data that need considerable time invested to solve them. It's worth noting that these are not necessarily different from the types of questions that relate to traditional publishing, such as provenance, legal, copyright issues, metadata, citation, etc. But where we've spent at least the last 2 decades working in an electronic form to address electronically these issues as they relate to traditionally print-produced materials, there are subtleties as they relate to data, specifically related to scale, integration, and reuse, which are relatively new compared with the issues that are related to traditional text-based content. None of these things listed here are simple problems to solve. However, the consensus process that the standards development community has developed is probably one of the best places to start. I don't have time to go into each of these issues in detail, but I'll highlight just a few. So this is just one example of the problems with data, and that being the fact that it's constantly changing. Some of these problems that when dealing with constantly changing data set as compared to, say, a traditional print product. So how does someone rerun an experiment or an analysis on a data set that is constantly changing? And from an issue of replicability of science, how do you know that you've produced the same results a year or 2 down the road when the underlying data set has changed? So again, for citation purposes, how do you cite a subset of the data as it appeared on X date when the initial researcher ran their analysis? How can you preserve a snapshot of that data set, particularly when you're thinking about the size and scale of data? If you wanted to preserve the version of the data that existed on X date so that you can cite it, this is certainly a problem if you can't even maintain the data set as it is in its entirety. We still don't have a good way to describe what the data set looked like at a certain point in time. There are certainly problems of managing the metadata at each deposit. Say if you're constantly depositing information, I'm sure anyone who's run a repository knows that the challenges of getting the metadata for any one particular project is difficult enough. Having to do so serially as data is constantly changed is kind of exponentially increases that problem. And then there are certainly problems of synchronizing different repositories of data as they are changed over time. Another issue that I've mentioned a couple times is scale. For a variety of reasons, our infrastructure isn't prepared to manage the data that we are creating. This is a quote from a report by IDC that came out in 2008, noting that I think predicting that in this year, almost half of the digital universe will not have a permanent home, and that in 2007 we surpassed the amount of storage capacity in terms of how much data is captured, replicated, and created on an annual basis. For example, often the best way to transport a large data set is through the sneaker net. That is, copy the data onto several large hard drives and physically move that drive or those drives rather than using the internet to transfer the data. In addition to investing in our infrastructure, other issues are related to scale. IT organizations are going to have to rush new tools and standards into the mix for managing data, for storage optimization, for unstructured data search, for database analytics, and resource sampling, so virtualization, as well as security. All of these are going to be required for the information infrastructure to be as flexible, adaptable, and scalable as possible as we move forward in using large-scale data. Yet another issue is that of intellectual property rights. I'm not talking here about access per se, but control of access is really predicated on ownership rights. One of the large issues related to data is that in the US, you can't copyright facts. However, you can copyright data in collections, so the form, the presentation, and the privacy of the data as an entity rather than the facts that are contained within that data collection. Another twist on this relates to the fact that when data crosses international boundaries, it assumes, the data assumes the legal characteristics of the host country. And in not every country, they have the same view on copyrightability of facts. And so this poses certainly a number of challenges related to data and data sharing, particularly within international teams. There's a great Nodalities magazine issue, which I note here, that talks in more detail about some of these issues. I have at the end of the slide set some more information about a variety of these projects. Finally, another critical question is that of provenance. So how can you be certain that the data set that you're looking at hasn't been altered or changed? Can you trust its source? Has the data been updated, added to, or appended since the analysis run in which you're looking at? And then there's certainly issues dealing with abstraction, which is a slight variance on the provenance question. And by abstraction, I mean when a data set is, say, downloaded from a sensor or satellite, you might not necessarily be able to keep the entire data set, and you will oftentimes extract critical elements of that data set for long-term preservation. So how does that issue then deal with the question, cause certain problems related to provenance? So I'm going to talk a little bit more in more detail about two projects of the many initiatives that are underway related to data. These two projects are two that I and NISO are directly involved in related to data and data management. As I mentioned, these are just two of a variety of projects that exist related to data publishing. So the first issue is data citation. And this is an image of kind of the culture of data citation. This image is from the Australian National Data Service. It's not unlike traditional citation culture and publication structure culture. You have a researcher on the left who creates a data set, puts it in a repository. That repository is assigned a DOI, not unlike a journal article. That DOI gets distributed in publications. Researchers then find it and use it, hopefully then developing some additional content or some additional publication referring to that data set, citing it in their own publications, using the DOI, which then eventually gets back to rewarding the original researcher, either through credit or traditional measures. Now, obviously, anyone familiar with the publication process is aware of this kind of culture of citation and recognition. And within traditional publishing media, we certainly know what a citation looks like. These are some citations from the Scholarly Electronic Publishing Bibliography. You know, in many cases, they're very similar to citations that have been in our industry, in the community for centuries. Although a few new tweaks, such as DOIs and handles, have been added to traditional citations. But what about citing a data set? These are 5 different examples of citations of data. 4 of them are actually from data repositories that are somewhat forward-thinking in their and advanced in their thinking regarding data citation. But even still, none of these citations are kind of standardized and don't go far beyond their own research community. One of the citations here, the chart, is actually one of the problems that we run into, in particular related to data citation. This is from an Economist article, and I'm sure the next speaker will kind of highlight this issue in more detail. In many cases, you simply cite the source of the data. Well, the source of the data only gets you so far. This is, there's probably hundreds or thousands of data sets available from the OECD, as there are from SEER, from the International Polar Year, from ICSPR, ICPSR, and the Land Cover Facility. We really need, as a community, to have some better understanding and rationale for how things get cited in our community. Oops, this is the one. So in 2010, CODATA, which is a Committee for Data and Science and Technology as part of the International Council for Science, approved the creation of a working group in 2010 during their annual General Assembly in Cape Town, South Africa. And that group is tasked with doing several things. The first is create a bibliography of existing literature and existing data citation practice, gather some information from stakeholders in the library, academic, publishing, and research communities, hold at least one meeting or workshop to help establish a foundation about the state of the art, and then work with national and international standards organizations to help develop formal state citation practices and best practices for how to go about citing data. As I mentioned, I help serve on one of these groups. And these are some of the issues that certainly are requiring attention and that we are exploring. So some of these issues are technical. So what are the metadata standards for describing data? Some of them are kind of scientific questions. How do we determine what should get added to the scientific stream? How do we deal with questions of peer review? Some of these issues circle around institutional issues that relate to how data is used in promotion and tenure and how they fit into the reward structure. Certainly some are financial. The question of support of the infrastructure is necessary. This leads directly into sustainability. Related to the technical issues are those of identifiers. Which are the appropriate identifiers for use in data citation? Are they DOIs? Are they PEARLs, ARCs? The legal and intellectual property rights issues that allow accessibility and reuse, as well as privacy. And then sociocultural issues about creating, as I noted in the earlier slide, about the culture of citing data and properly attributing data to the creators. So the group has been working about a year now. We've compiled a significant bibliography. We also hosted a 2-day meeting in Berkeley, California on these issues in October. We'll be drafting out, we are working on drafting out a report, and that report is due out in January on the meeting in Berkeley. We've also formulated a survey for 3 of the constituent groups, the repository managers, the publishers, as well as the funding organizations that contribute to the data sharing environment. Next steps for the group will finally get the survey out the door in the first quarter of next year and then start compiling the results. as I noted, we'll be reporting out of the Berkeley meeting. And then we'll be beginning work on our final draft of the report. Hopefully we'll have that report out next October. The next project I wanted to touch on is actually a NISO project on supplemental materials. And this is actually a pretty pressing problem for the journals publishing community. This is some information courtesy of Ken Bouchamp at the American Society for Clinical Investigation and their journal, Clinical Investigation. In 1999, none of the articles that they published had supplemental materials attached to them. In 2011, that has increased to 95% as of so far this year. So 95% of the published materials in the Journal of Clinical Investigation have some form of supplemental materials. This has created such an issue that a number of publishers have thrown up their arms and said, we're just not dealing with supplemental materials any longer. But we as a community really need to address this. So this project began in 2009. Sasha Schwartzman, who is on the staff of the American Geophysical Union, conducted a short survey of publishers, more or less saying, we're seeing a lot of this supplemental materials. What are you seeing? And how are you dealing with it? So Sasha distributed the results of that survey on the Crossref Technical Service listserv, and it generated a lot of discussion in the fall of 2009, particularly at the Crossref annual meeting in 2009. Shortly thereafter, in about, I think it was January of 2010, NISO and NFACE partnered to host a thought leader meeting in Washington on this issue. We brought together about 80 people from publishing libraries and some service providers to really think about these issues. And in partnership with NFACE, NISO launched a working group in the spring of 2010. That working group is nearing completion of the work on a draft recommended practice, and that'll be available in the first quarter of 2012. So the goal of this process is actually to look at the publication structures necessary for communicating supplemental materials as part of the publication process. We're not trying to address every issue, not trying to address all data questions. But once an author has decided to put their information into the publication stream, how should the publishers deal with those issues? So one of the core questions here is, what is supplemental? What are what's critical to understanding? What is supplementary to understanding? And what is ancillary to understanding? And it's important to note here that the form of the content, if that content is text, video, and data and application, is not key to whether something is supplemental. I often use the example of a video of water hitting a plane in fluid dynamics. You can convey more information with a 30-second video than you can with 10 pages of text. So that in that particular case, the video might not be supplementary, even though it's not what we had traditionally considered traditionally published. So one of the things that we've broken out into a variety of areas. So whether something is integral, additional, or related content. And integral content is essentially pseudo-supplemental. It's really essential and treated as if it were essential. And then there is additional content, which is truly supplemental, useful, and somewhat optional. And then there is related content, which could exist somewhere that is actually curated by someone other than the publisher. And then there is things like that are curated by the individual, which are really ephemeral and not really part of this process. So we broke up this working group into two areas. We've got a working group that's looking at the business practice issues and another that's looking at the technical issues. The business issues that we're looking at and developing recommendations of are related to selecting and editing and managing and hosting the content, ensuring its discoverability, maintaining its links, providing context, preserving, and then rights management. And these are some of the guidelines. I just included them here so that you'll have them in the slide deck, which I know you'll be receiving shortly. And this goes through some of the guidelines related to the difference between integral content and additional content. So integral content, kind of summarizing these those 2 pages of charts, is basically integral content should be preserved, maintained, and curated and edited in the same way that traditional text content had been. And additional content were a bit more flexible about preservation and rights, etc. The technical group is looking at some of the other, these obviously technical challenges, particularly related to metadata and the description and relation between the supplemental materials in whatever form and the traditional content. How do you identify and link that content to the, say, traditional article? How do you group and package them? How do you manifest the package so that you're aware that you have all the items? There's certainly a variety of challenges, so granularity, relationships, heterogeneity, as well as the hierarchy of those supplemental items. And then the groups, both of the groups are looking at some overall issues about the perceived importance of supplemental materials, the costs, the business models that are associated with them. Oops. So a couple things about what the future holds. Unfortunately, my crystal ball doesn't work very well, but just some things to think about. This is one of my favorite cartoons. Deals with how we end up with ever more competing standards. Each community is doing its own thing for its own reasons to support their own needs, and this certainly isn't wrong. It's completely understandable. However, increasingly, it causes problems when as we're entering into an era where machines are really talking to machines, and interoperability, which is how access to data really can be truly valuable. Sure, a human being might be able to decipher the difference between biology, ecology, population science from voting results. However, computers can't. Just as one example, we really can't do anything if we don't have the right metadata and exchangeable metadata. A table filled with figures are just numbers to a computer, and without context, a 22 is as useless a figure as 356,000 when one is in tons and another is in grams. And maintaining that data is a critically important challenge in this process. There are a variety of potential work areas related to standards in this area. Certainly some systemic metadata questions. What is the form of this information, its structural components? There are archival issues, both at physical level storage, but also migration, bibliographic information, certainly delivery and reuse. Rights issues are tremendously challenging, as well as something called data equivalence. So how do you know that you have one, that this thing and that thing are equivalent or contain the same data? It's kind of similar to the Ferber question of a hardcover and a softcover version of a book, different manifestations. Those same questions apply to data. One important organization that's been developing quickly over the last couple of years in this space is a group called Datasets. It's an international consortium led by a German National Library, And their goals are to establish easier access to scientific research and increase the acceptance of research data for distributing content. They have 19 members from 11 countries, and they're doing some terrific work on the use of identifiers and the citation of data. Do take a look at some of the work that they're doing. As I mentioned earlier, here's a number of links. These will be available in the slide set. These are various projects that are underway within the community. As I said, this is just a very small sampling of some of the things that are going on. There is going to be a lot of information taking place as we move forward. So, also want to highlight in the summer of 2000, NISO published a special issue of Information Standards Quarterly. Talks about a number of these issues. That URL is there. ISQ is available free and open access for anyone who wants to take a look. So with that, I'm going to pass the presenter mode on to Terry so that she can move us forward. Terry?
Yes, hi. Thank
Great.
you, Todd. I'm trying to get it transferred. Okay.
There you go.
Thank you very much. So I'm going to talk a little bit about OECD's approach to publishing data sets. In this webinar, I'll talk to you about how we've developed standards for publishing data sets and tables, and how OECD have applied the standards on OECD iLibrary platform. For those of you who are not familiar with the OECD, the mission of the Organization of Economic Cooperation and Development is to promote policies that will improve the social and economic well-being of people around the world. OECD is one of the largest publishers of economic statistics and policy information in the world. Each year we publish over 150 books, and on an ongoing basis, 18 periodicals and about 40 statistical databases. And through OECD iLibrary, OECD content is available to an estimated 25 million researchers, faculty, and students at more than 1,200 universities, think tanks, government agencies, and international organizations worldwide. OECD developed a metadata schema for data objects which is compatible with existing bibliographic management and citation systems, making it possible to cite and manage published data sets and tables using the same tools used to manage journal articles and books. And this has made it possible for search engines, abstracting and indexing services, and library catalogs to reference data sets. So I'll go ahead and talk to you in a little bit of detail about how this came about and what we've done. So as Todd had mentioned earlier, data is very difficult to find today because there are a number of search tools and that researchers use to look for data, such as Scopus or Google Scholar, for example. And one of the problems is that if you just take, for example, the content of Scopus, you'll see that there are titles, journals, book series, and lots of information, but the data is missing. It's eventually, hopefully, going to get there, but today it's missing. So it makes research much more difficult and challenging. And with research, we often use citations. This is an extract from an IMF staff paper, which shows the current account deficits in rich countries, was the title. Basically, if you look at this, the main problem is that the author has indicated the source is an OECD database. And the problem for someone trying to follow the links is that OECD has thousands of web pages. We have thousands of published tables, over 400 data sets. So it's very challenging for the person trying to find this precise database to find the information. And because the citations to data are inconsistent and there are no established standards, it's very difficult to use this information in a reliable way. So we looked at this issue starting in 2006 and tried to come up with ways to deal with the issues of data discovery and citation. What we set out to achieve was to make citations to data sets and tables to make data as easy to discover as other works, to make it so that authors would be able to cite data sets and data tables as they do with publications, librarians to be able to catalog data sets and tables like other published outputs, publishers to be able to link to data sets and tables, and discovery systems could find data sets and tables. Many of our publications contain links to underlying data behind graphs or charts, which we call stat links. Data sets and data tables should essentially be as easy to discover and cite as any other published work that we have, such as journal articles or working papers. And we also realize that when users are looking for information, they may not know whether the information is actually in a publication table or a data set. And for this reason, we think discovery systems need to be able to find published data sets and tables integrated in an integrated manner. So OECD's publishing approach consists of 4 steps. First, we define the bibliographic standards for data sets and data tables, catalog data sets and data tables, online publishing and citing, setting up a citation rule and syntax for data sets and tables, and then making the data available via other discovery channels. So I'll go into detail about each of these steps. The bibliographic standards definition. When OECD established standards, several communities were active. However, the standards had yet to evolve. As you know, they're still evolving today and under discussion. For example, at the time, Datasets had not yet been founded as an organization, as a consortium. And when we originally published a white paper on the need for publishing standards for data sets and tables, we proposed a standard based on existing standards for e-journals. And this was in 2008. We discussed standards with NISO, with Crossref, with other communities that were working on standards at the time, and also revised the paper and reissued a revised version in 2009. The objective we had was to stay as close as possible to existing systems and standards so that it could as easily as possible integrate into existing network of publishing and citation systems. We also involved a bibliographic specialist in the process of defining standards. So at a high level, the concepts that we identified for data sets were 2 different types of concepts. One being a collection of data sets, which could contain a sub-collection of data sets, and then individual data sets, which would normally be a set of related thematic data sets, a related database, or it could be published as a standalone data set. At the top level, the collection of data sets and the standalone data set also have an ISSN because these are offered as products on our online platform, subscription products. We also, for tables, came up with the concept of collections of key tables, which could hold key tables and key table additions as their dependents. The items at the top level on the collection of tables also have an ISSN and are offered on our online platform. So cataloging data sets and data tables was carried out in 2009. We cataloged the data tables and data sets into our central bibliographic database using the new standards, together with all of our books, journals, and papers and other published items. In order to do this, we had to make changes into the way our publishing unit was organized. We hired statistical editors in the publishing unit to be able to carry out editorial reviews on the data sets and data tables. We've carried out reviews on over 400 data sets. For example, in order to be able to look at the data sets that are published across the organization and to distinguish and harmonize titles across data sets in the organization to make them unique and distinct, and to be able to build the descriptive publishing metadata around those items. We also worked with authors to improve the data and statistical metadata, which is the metadata which describes the data set content, so that issues with understandability, readability of that could be improved. And by using statistical editors or editors who were specialized in statistics, they were able to speak with their peers and be able to help make improvements on that area. We hired a librarian on our staff to help us catalog the information and to ensure that we were following as close as possible to bibliographic, standard bibliographic cataloging rules. Online publishing, we released the data online on our online publishing platform, which is OECD iLibrary, in 2010. All of the data tables are published together with all of the other outputs of the organization. For instance, in this platform, we are able to see the integrated results or the search results from searching for health statistics on the platform. And we can see in this that we have data sets together with books, chapters from books, data tables from publications and graphs. And this provides the researcher an option of different types of information, and also provides the format so that they can choose between the options available. When it comes to publishing data sets, each data set has, each collection of data sets have its own home page as well as data sets. They each have a DOI. When the user clicks on the data button, they're able to access the database at either at the collection level or at the database, data set level. This also contains information that is coming from the publishing metadata, such as classification, keywords, countries covered, time range, and publication date, the ISSN and the DOI for the data set. For key tables, we when we publish the key tables, we publish them by within their statistical collection. And key tables on this page are shown at the very top of the screen. The economics key tables from OECD is the collection, and the tables and their additions are shown at the bottom half of the screen. We also are able to publish tables in books. As you can see on this slide, you'll see that main economic indicators is one of the books that we publish, and the individual tables are listed in the table of contents. So the user can go straight to the tables inside the table of contents or from the search results. So citation is another area that we had to tackle, and we established citation syntax based on, as close as possible to existing citation rules. In this case, citation is at the dataset level. We cite it at the dataset level to try to help the user find exactly which dataset that the information was related to. And we do not cite at the data collection level. The key tables are cited as part of a table collection. And because we have entered the publishing metadata into our bibliographic database, we're able to establish links between the database. This is a page for a data set, which shows at the white part at the bottom of the screen the data set, and at the top the data collection that it belongs to. In here you can see that we have the other language that it's available in. We have links to key tables that are related or drawn from this data. We have related titles such as working papers or even external links. Some of these links are created dynamically based on the thematic cataloging in the bibliographic catalog, and some of the links are added by the statistical editors based on relevance and appropriateness. Each data set and table is assigned a unique and persistent DOI referenced in Crossref database, which allows linking between the data sets and the published articles, books, or chapters. This allows us to link with publications that are outside of OECD systems that other publishers may link, so that the links can be active in the full system and so that citations can be counted and acknowledged back to the authors of the data set. And we also are able to generate from the publishing metadata in the bibliographic catalog MARC records for data sets and key tables. This is an example, a very big list of the MARC record fields, and it shows that we're able to send MARC records for key table and key table collections of data sets, as well as data sets. The future work is to evaluate our standards to be able to enhance them to manage dynamic and frequently updated data sets, as well as static data set additions and archives. We also plan to export the publishing metadata to various channels, to start exporting to institutional catalogs and specialist portals such as REPIC. REPIC is actually an economic specialist site used by researchers to look for information, and it does receive a lot more traffic than the OECD homepage, and we are already sending working papers to this site, and it's as a result researchers are discovering and economists are discovering more information from the OECD, and what our hope is that they will also be able to discover data from this portal. And that's about it, but I'd like to thank you very much for your attention, and I'll turn it over to the organizer.
I'd like to thank Terry and Todd. This was a technical miracle in a way. I'm in Dallas. My technical support is in Missouri. Todd's on the East Coast of the United States, and Terry is in Paris, France. So I'd like to thank all of them. I don't see that you have any questions at this point.
I see that there's the NISO issue was not
It's
open
not
access.
up.
I will double check that and make sure that it is. It should be. If it's not, we will certainly open it up. I don't know why it wouldn't be.
If you have questions, there is a question, should be a questions box on your screen. There is a question now. We have a question. What do you mean by the author of the data?
This is actually, Terry, do you want to take a swing?
Yeah, I can talk to it. From OECD standpoint, the author of the data is actually the directorate or the unit that's responsible for producing the data, and usually involves more than one person in our house, but they are the ones that actually do the harmonization and add and calculate the numbers that come out.
Okay, here's another question.
This before we move on, this is something that that actually NISO is looking to explore a little bit. In that, as I mentioned, we're kind of looking at some of the data equivalence questions. It's kind of what are the differences between the distribution of content in traditional media versus the distribution of data, and within the kind of Ferber model, there is an author or a creator of content, but within the scope, the structure of data, it's not quite so clear. The information that's being created by the Large Hadron Collider, we don't, is it CERN? Is it the team that's conducting the experiment? Is it the actual machine? Is it the guy who built the sensor? So it's not nearly as simple a question, particularly when you get into some of these scientific data experiments. The Sloan Digital Sky Survey or the Hubble. Is it the actual satellite? So these are really difficult questions, actually, and we need to spend some significant time thinking about them.
Okay, we have another question. Does OECD publish metadata as RDF linked data, or do they plan to?
Actually, our online library, OECD iLibrary, is RDF ready. We are working on the glossary and the taxonomy on how we can make it link in with linked data. That's the challenge, is that it's still in the early stages of evolving in the communities.
Okay, I have another one. Has the National Science Foundation considered adopting a standard for citation of data in relation to its data archiving mandate?
I certainly don't speak on behalf of NSF, but as far as I know, they have not. We are in regular, well, at least the data site group is in regular contact with some of the people at NSF about this, and have had some conversations with NSF representatives about their data citation practices.
Okay, I have one last question, or at least one that hasn't been answered. Do publishers like the Journal of Clinical Investigations have usage data of their supplemental information?
Not
for me.
This publishers are all generally reticent to share usage information. So as far as I know, there is not specific information, although I'm sure this is something that most publishers are tracking. And from the publishers that I have spoken to about this, the usage of supplemental materials is relatively low, particularly related to the actual journal content. But then it often depends on the type of supplemental material that it is. So again, if it's kind of a video or something that is more integral to the understanding of the article content, then those supplemental materials, and I'm reticent to use the term supplemental materials, but those materials are often much more significantly used than, say, someone's lab notebook, which might be, ancillary material.
I think that's all the questions we have so far. If we get any in the meantime, Terry and Todd can answer them offline. You'll get a email that will have those answers with it. I need to give some other announcements from ALCTS unless Todd and Terry have anything else.
I see that there's one more question about the supplemental materials and whether publishers have data management policies regarding supplemental materials.
Okay.
At the moment, few publishers do, and that's part of the reason that NISO is pushing forward this project. But thank you for ALCTS for putting this webinar together.
The ALCTS Continuing Education Committee is always looking for topics such as the one we had today. If you are interested in a particular topic or really would like to propose one that you would teach, I have a link to the ALCTS website form that you would need to fill out. I also want to tell you a little bit about a couple of forthcoming webinars. They are on the calendar on the ALCTS website. We do a lot of webinars on institutional repositories, licensing, preservation, cooperative collection development. Those are all coming soon. One in particular that they want me to tell you about is at the same time as Midwinter, coming in January. It's the first virtual Midwinter Symposium, and it's about leadership. It will be covered over 5 one-hour visits during the week of January 9th through the 13th, one every day. And here's some examples of the speakers that will be presenting about leadership. All of this information, again, is on the ALCTS website. So coming at leadership from a lot of different angles. I'd personally like to thank both Todd and Terry today. Here's their contact information, and I'm sure they'll be willing to answer some questions if you send them an email. With that, I'd like to thank you from ALCTS and our presenters.